This video is an added extra functions video on top of the notes that you might have and the videos that are already up. This video in particular is going to look at quadratic graphs and the questions that might come up in relation to real life quadratic graphs. The first question here is one that I've taken from a book, and then the other questions are all past exam questions, so they're really important that we know how to do these types of questions. So all of these questions will be based around quadratic graphs, using quadratic graphs, relating them to real life, and drawing quadratic graphs as well. So example 1 here says, given that f of x is equal to 4 minus 3x minus x squared, where x is an element of OR, bearing in mind and remembering that OR stands for real numbers, and a real number is any number. So then it says, copy and complete the given table. So I'm not going to actually read the rest of it because I'm just going to copy and complete the table first. So they've done the first one. So the second one then would be 4 minus 3 times minus 4 squared, and so on. You can fill in the rest of the table then. So you'll be left with this. So when you type in minus 4, the y value you're going to get is 0. When you put in minus 3, the y value you're going to get is 4. When you put in minus 2, the y value you're going to get is 6. When you put in minus 1, the y value you're going to get is 6. When you put in 0, the y value you're going to get is 4. When you put in 2, the y value you're going to get is minus 6. So that's the first part done. And sometimes in the questions, they don't actually label the parts I, and IV, or so on. So the best thing to do is then kind of highlight and tick it as we go along. So for this question, the first thing we needed to do was copy and complete the given table. And we've got that done, so I might put that in a green tick. The second thing it does is says, draw a graph of the function in the domain minus 5 to 2. So I'm going to move this up a tiny bit, make it a bit smaller, and I'm going to draw my graph. Now, of course, your graph is going to be nice and neat. Mine is just a little bit messier because, of course, I'm drawing it on the whiteboard here. You should have graph paper, you should be using a ruler, and you should be labeling everything nicely. So you should end up with something similar to this. Next thing we have to do is plot the points, and remember, it's a good idea to plot the points maybe in a pen or a different color pencil, just so that it's a little bit different and easier for you to read. So the first one we have is minus 5, 6. So that is approximately here. The next point we have is minus 4, 0. The point after that is minus 3, 4. Then we have minus 2, 6. We have minus 1, 6. 0, 4, 1, 0, and then 2, minus 6. So again, you need to draw that graph in. I'm going to draw it in green here, making sure that you draw the graph freehand and you also do it with pencil. Now, of course, my graph is a little bit messy. However, I'm sure yours are going to be much better than mine. You're going to be drawing it on a proper graph paper and you're going to be using a pencil. So that's the next part. So if we go back to what it was asking us, it asks us to draw the graph of f of x in the domain minus 5 to 2. And we've got that done. So we can just put a little tick beside it. So if the graph represents the temperature in degrees Celsius taken every 2 hours between 6 a.m., which is minus 5, and 8 p.m., which is 2, in a certain city, use the graph to estimate the temperature at 11 a.m. So, taken every 2 hours. So what I would do then is I would say, okay, well, this is 6 a.m. This is 8. This is 10, 12, and then it will go to 2, 4, 6, 8. So this is a.m. So just making sure we know what's on the x and the y axis. So the x-axis then is time, and the y-axis then is temperature. So here they want to know what the temperature is at 11 a.m. So 11 a.m. is between 10 and 12, so it's going to be minus 2.5. So what we should be able to do is draw a line straight the way up and straight the way across, and we should get a time approximately where x, so when x is equal to minus 2.5, we should get that y is equal to approximately 5.2. So the answer there for here is 5.2 degrees. The next thing then we have for B is we want to figure out the time when the temperature was at its highest. So that's its peak. So that's going to be, I might do this one in yellow, that's going to be when it's at the top. So all we have to do for that is bring a line right the way down. So we get for that an answer of x is equal to minus 1.5. Now we need to then figure out what minus 1.5 is. So minus 1 is equal to 2 p.m. minus 2 is equal to 12 p.m. So halfway between that, so minus 1.5 would then equal 1 p.m. So B is 1 p.m. So if we go back here, we've got the first two done. So A was time to the temperature, we've got that done. So we can put a little tick beside that. And then B was figuring out the time when the temperature was at its highest. We figured that out, so we can put a little tick beside that. Then the next one, part C, was the times when the temperature was 3 degrees. So for that, what we do is we figure out where 3 degrees is. And 3 degrees was here. So we draw a line straight away across for 3 degrees. And every time it hits the graph, so it hits the graph here, and it hits the graph here, we go right the way down. So for that, I'm going to come right the way down here, and I'm going to come right the way down here. So for me, that looks approximately where we have x equal to minus 3.3 and x equal to 0.3. So we need to get the time then when it's 0.3. So we have that my 0 is equal to 4 p.m. and 1 is equal to 6 p.m. So we're figuring out, so there's 2 hours between here, so that's 120 minutes. And we need to figure out 30% of that time. So that would give us 36 minutes. So we need to add 36 minutes onto 4 p.m. So the time would be 4:36 p.m. would be the time when it is at 3 degrees once. I'm going to zoom out here a little bit more and come down. We also had that x was equal to minus 3.3. So that's between minus 3 and minus 4. Minus 4 is equal to 8 a.m. and minus 3 is 10 a.m. So again, there's 120 minutes between these. And I would say we are about 30% to the left. So again, so however, this is going to be approximately, I would say, 9:24 a.m. And the reason why I say that is because if minus 3 is 10 a.m., we're about 36 minutes before 10 a.m. So 60 minutes, take 36 minutes, is going to give us 24 minutes. So we're approximately 9:24. So then the answer here we have is 4:36 and 9:24. So if we go back up then and have a look at the question that we were doing. So the thing it says here, it says it wants us to estimate the times when the temperature was 3 degrees. And the final thing it wants us to do is figure out or estimate the number of hours the temperature was at or above freezing. So the temperature is above freezing when y is greater than 0. So we know that y is greater than 0 above the x-axis. So we're looking for everything above the x-axis. So that's from x minus 4 to x equals 1. So that amount of time would be, I'm going to write this down over here. So d. So it's between x equal minus 4 and x is equal to 1. So minus 4 is equal to 8 a.m. and 1 is equal to 6 p.m. So the time difference between that, or the amount of hours between that, will be 10 hours. So then we can go back up here and we can put in what we have. So we know the number of hours the temperature was above or at freezing point is 10 hours. So we've got that done. So that's that question completely finished, and I'm hoping that makes more sense now. The next few questions that we have, I'm going to go through our past exam questions. So for example, example 2 here is the 2019 question 7. So this one says, a camogie goalkeeper on a level pitch hit a ball straight up into the air. The path the ball travelled can be modelled by the function f of t, which is equal to minus 4t squared plus 16t plus 1, where t is time in seconds from the ball is hit, and f of t is the height of the ball in meters above the pitch. The ball landed on the ground without being hit again. So just to kind of, before we answer any questions that they have here, so they've given us the function f of t, which is equal to minus 4t squared plus 16t plus 1. This is the same as writing y is equal to minus 4t squared plus 16t plus 1, where f of t is the height of the ball, in meters above the pitch, and t here stands for time. So the first question here says, at what height was the ball when it was hit by the goalkeeper? This question then is asking us, how high was the ball when the goalkeeper hit it? So we're thinking about the function that we have here, and we're looking at the height of the ball after it is hit. So we need to figure out what time is it going to be hit at. And well, when it's hit, time is equal to 0. So what we need to do then is just figure out what the y is, which is the height of the ball when the time is 0. So if y is equal to minus 4t squared plus 16t plus 1, and time is equal to 0, well then y is going to be equal to minus 4 times 0 squared plus 16 times 0 plus 1. So we'll get that y is equal to 1. So the height of the ball was 1 meters when it was hit. Now, if you're wondering where I got the meters from, it says the height of the ball in meters above the pitch. So when it was hit, so when time was 0, the height of the ball was 1 meters. So then the second part here, it says complete the table below to show the height of the ball at various intervals during the first 4 seconds of its flight. So we should be able to make a little table here. So we have the time, we have the function, which is minus 4t squared plus 16t plus 1, and then we have our y here at the end. So they've given us a few values as well. So they've given us 0, they've given us 0.5, they've given us 1, they've given us 1.5, they've given us 2, 2.5, 3, 3.5, and 4. So we can fill all of that in. When you do fill it in, you will get the following. So then you can fill it into the table here. Now, of course, if you're an examiner and you're under time pressure, you don't need to draw out our table. But however, it is really good practice to draw out our table. It makes it sure that you're not going to make any mistakes and that you're getting everything correct. But then we can fill in the table here at the top for B, and you will get the following at the end. So that's question 7 on 2019 part A and B completely done. The next part, so BII, is what we're going to look at next. It says, on the grid below, draw a graph to show the height of the ball while it was in the air. Now, I've copied the table that we filled out in part I, and I have it up here on the left-hand side. So we're just going to use that to fill in the graph here. So when time is 0, we have a height of 1. So I'm going to put that in here. When time is 0.5, the height is 8. So I'm going to fill that in here. And the time is 1. It is 13. When time is 1.5, we have 16. We have 17, 16. Now we've plotted all the points, so the next thing we can do is draw the graph. You'll be doing this all in pencil. And that's the graph. That's part BII done, so we've just drawn the graph, that's perfect. Part C then says use your graph to estimate, and it says show your work on the graph above the length of time that the ball was in the air from the time it was hit until the time it hit the ground. So for this one, I would say, so it went into the air at time 0, and then it was in the air all the way up until time, I would say, approximately 4.1. So the amount of time that it was in the air was 4.1 seconds. So the length of time the ball was in the air was 4.1 seconds. The second part then says, use your graph to estimate the length of time the ball was 10 meters or more above the ground. So we want 10 meters. So the height here is 10 meters, which we can see here. I've just highlighted in green. So if we go across here, what we should be able to see is that this will hit at 2 points. And if we bring where it hits at those 2 points right the way down to the x-axis, we should be able to see how long it was in the air. So what we get is it's about 3.4 here, and it's about maybe 0.6 here. So it was 10 meters above the ground from 0.6 seconds to 3.4 seconds. So we can figure out the total time by taking 0.6 from 3.4, and we get 2.8 seconds. And that's this question completely done. Example 3 then is from 2017, and it is question number 8. And here it says a company makes and sells fiber optic cable. It can sell at most 200 kilometers of cable in a week. For a certain range of its production, the company has found that profit can be modeled using the function P of x is equal to 275x minus x squared minus 1000, where x is greater than 200. In the function, x is the number of kilometers of fiber optic cable sold, and P of x is the profit. So if we have a look here, we have the function P of x is equal to 275x minus x squared minus 2000. Now, we have P of x is the profit, and we know that that could also stand for y. And x here, x is going to be the number of kilometers, so kilometers of fiber optic cable sold. Now, so at least we understand what is going on in the type of function that we have here. Question A says, use the profit function P to find out how much money the company loses if it does not sell any cable. So that would, in terms of how much cable being sold, that would be 0. So in this case, it would be x equal to 0. So to fill that in, it would be P of 0 is equal to 275 times 0 minus 0 squared minus 2000. So when we have P of 0, we get an answer of minus 2000. So the company loses 2,000 euro if it sells no cable. So that's part A done. In part B, in a particular week, the company made a profit of 8,350. Find the number of kilometers of cable it sold that week. So again, we have the function here, P of x is equal to 275x minus x squared minus 2000. So in a particular week, their profit was 8,350. So we let the 8,350 equal the profit function. So we need to figure out how many kilometers, so we need to solve for x. So you can see here that we have a quadratic, so I'm going to plus x squared to both sides, plus 2,000 to both sides, and minus 275 from both sides. So that will leave us then on the left hand side with x squared minus 275x, and then we have 8,350 plus 2,000, which will give us an answer of 10,035, and that's going to be equal to 0. Now I would solve this using the minus b formula. So we would have A equal to 1, B equal to minus 275, and C equal to 10,350. So the minus b formula is we have x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Here then we have x is equal to minus b, so that would be 275 plus or minus the square root of b squared, so minus 275 squared minus 4 times 1 times 10,350. Then all of that is over 2 times a, which is 1. Now when you type that into your calculator, you're going to get two answers, one positive and one negative. So when the positive one, it's going to be x equal to 230 and x equal to 45 when we have the minus version of it. So going back to the question, it said in a particular week, the company made a profit of €8,350. Find the number of kilometers of cable it sold that week. We got two answers here. We got the answer of x equal to 230 and x equal to 45. However, going back to the question, it says that x is less than or equal to 200. So if you look at the two values we have here, so we have 45, which is perfect, but we have 230, which we can't use. So if we think about the number of kilometers of cable that it sold, it could only sell 45 kilometers. And that's that question done. Now, part CI says, the table below shows some of the data representing the profit on sales. Use the profit function, P of X, to complete this table. So again, like in the other ones, we draw out a small table. So we have X here. We have the profit function, which is 275X minus X squared minus 2000. And then we have our Y value. So we draw a little table and we fill it in. So we'd have 50, 60. They've done 70 first, so we'd have 80 next, 90 and 100. And next thing, you fill that in. When you fill out the table that we've made, you should get this, which is below, and then you should fill it into the table up above as well. Now, again, as I said, if you're under time pressure in an exam, you don't need to draw the table that I've drawn. However, it is really good practice because it means that you're not going to make any mistakes. If you are not going to draw the table, the main thing I would do, just to make sure that you have the function correct and that you're doing everything properly, is type in 70 and make sure that you're getting 12,350. And if you're not getting 12,350, you know that you've got the function wrong, so you need to go back and check what you're putting into your calculator. But that's question C, part I, done. So part II then says, use the data in the table to draw the graph of the profit function on the axis below for x between 50 and 100. So I've then copied the table that we had on the last page over to this page so that we can use. So we're just going to fill it in now. So the first one we have is 50 and 9250. So that would be approximately here. The next one we have is 60 and 10,900. So that would be approximately here. The next one we have is 70 and the profit we get for that is 12,350. So I would say that is approximately here. Then we have 80,360. That would be approximately here. 9, which is 14,650, which would be approximately here. And the last one we have is 100, which would be about 15,500, which is here. Then we just need to join the dots together, so you should get something very similar to this. So that's part BII completely done, and then part III says use your graph to estimate the lower and upper ranges of sales in kilometers of cable in order to make a profit between 10,000 and 14,000 in a particular week. So we're looking at a profit of 10,000, so that would mean we would need to come across from 10,000 and down So I'm going to say that that's about 55. And we also are talking about 14,000. So we go across 14. And then we come down around here. And I'm going to say that that is approximately 83. So then to figure out, so I would say the lower limit would be 55 kilometers. And the upper limit would be 83 kilometers. And that's this question completely done. So that brings this video to a close. It just goes through 3 main examples of quadratic formulas used and quadratic functions used in everyday life. If there is any questions, you can get in contact with me, but I'm hoping that the questions that you'll be doing will be very similar to this and will work out very similarly.